Tennessee State Standard is to know the formulas for the volumes of cones, cylinders, and spheres and use them to solve real-world and mathematical problems. New lesson objective, I can calculate the volume of a cylinder, a cone, or a sphere. All right, let's watch Phineas and Ferb.
How many jelly beans in the jar?
Oh, I am really good at solving these kinds of problems.
So the base of the jar is pi times radius squared.
You're measuring the radius in centimeters, right?
No, inches. That way the inch fractions work with pi is 22 over 7.
You do not use 3.14 for pi?
Oh, for crying out loud.
There, 0. Okay, technically that is correct, but you did not show your work.
I will in about 20 minutes.
All right, so that was just a little intro to volume, a little fun cartoon. All right, so yesterday or today, depending on when you watched it, we looked at volume of cylinders, the volume of cones, and the volume of spheres using the Rice and the models. And we found the volume of a cylinder to be the area of the base times the height, is the area of the base times the height. So think about when you used the cylinder, what shape made up that base? So since a circle is the base of a cylinder, we can use the formula for the area of a circle, and the area of a circle is equal to pi times r squared, to find the formula for the volume of a cylinder, which is the area of the base times the height. So the volume of a cylinder is pi times r squared times h. So let's write that so we can use that. Volume equals pi times r squared times h. And this is definitely calculator problems. So for A, volume equals 3.14, because that's what they tell us to use, times 3 squared times 10. So the volume equals 3.14 times 3 squared, that was not right, 3.14 times 3 squared times 10. That gives us a volume of 282.6, and then that would be inches. You have to use your label, and then cubed. Since it is three-dimensional, our exponent is a 3, and it has to go after the label. All right, so B actually gives us the diameter. We need the radius, so we have to divide the diameter by 2, which gives us a radius of 3.2. So volume equals 3.14 times 3.2 squared times our height of 13. And even though that's lying on its side, the height is still 13. So our volume equals 3.14 times 3.2 squared times 13. And that is equal to, my phone's going off, I'll answer it later. That is equal to 418, and that is centimeters cubed. All right. Now, we learned yesterday that it took 3 cones to fill a cylinder. So a cone is actually 1/3 of a cylinder. So we can use 1/3 of our formula. We can add 1/3 to our formula. So the volume is 1/3 pi r squared h. All right. So volume equals 1/3 pi r squared h. So volume equals 1/3 times pi times r, which is 2 squared, times the height of h. So 1ABC3 times 3.14 times 2 squared times 8. So that gives us a volume of 33.5 inches cubed. B, volume equals 1/3 times pi times the radius of 8 squared times 9. So the volume equals 1 ABC3 times 3.14 times 8 squared times 9. And that equals 602.9 feet cubed. All right, and then we found the volume of a sphere was twice the volume of the cone. So it would be 2 times 1/3, or 2 times 1/3, which is 2/3, 2/3 pi r squared h. 2/3 pi r squared h. And we know that h is 2 times r. So that would be 2 times r times 2/3 times pi times r squared. We can put our numbers together. 2 times 2/3 is 4/3. R, put our variables together. R times r squared is r cubed. So that's where our formula comes from, 4/3 pi r cubed. So volume equals 4/3 pi r cubed. Volume equals 4/3 times pi times 2.1 cubed. So 4/3 times pi times 2.1 raised to the third power. Our volume for this sphere is 38.8, and that's centimeters cubed. Our volume for B, 4/3 times 3.14. And since this is 7, half of 7 would be 3.5 is our radius, so times 3.5 cubed. 4/3 times 3.14 times 3.5 raised to the third power is 179.5 centimeters cubed. I think this one will work together, so you can leave that blank and we'll go over it tomorrow. Our Tennessee State Standard is to know the formulas for the volumes of cones, cylinders, and spheres and use them to solve real-world and mathematical problems. Your lesson objective was to be able to calculate the volume of a cylinder, a cone, or a sphere. And that is the end of our lesson.